Okay, Jennifer. All right. I see what you've written here. I don't have exactly the same thing. That's why I asked you to check on the question. I'm not sure if it works out to the same thing. I don't think it does. Like ln of 1/3, I'm just looking here. Ln of 1/3 divided by -3 is not the same as ln 3 divided by 3. So I'm not sure if that's correct or if it's the question that's not correct, and so that's why I asked you to check on it. But in the meantime, what I did is I worked it down all the way down to the x value, and with the derivative, with what I've got working with the question that you gave me, I end up with x equals ln 1/3 over -3. Now, if you evaluate that on a calculator, you get x equals 0.3662. So the y value, or the f of x value for that, then, I'm just going to work up here now. If you go back in f of x, you would end up putting in 0.3662 plus e to the -3 times 0.3662. And what happens is you do end up getting that 0.6995 value that you gave me. So I'm just thinking that maybe there's a typo in one of your emails. All right, so basically that's the y value when this is the x value. So that's a point. And it's an extreme point, and so it could be a minimum or it could be a maximum. What happens is when they use the word absolute, so when it says find the absolute maximum or absolute extrema in this case, they're giving you an interval between -1 and 3, and those are x values. So between -1 and 3 on the graph is the only place where we want to look. So x equals decimal 3662 is definitely in that interval. It's going to be just between 0 and 1 in there somewhere. So it counts as one of our extreme values. But what we also have to do is check to see what's happening in the boundary areas, because absolute, what it means is if I have a graph, let's do a graph with a maximum and a minimum, okay? So I can clearly see that that graph has a maximum here and a minimum here. So I would say, therefore, the extrema are at this point and this point, and I'd work those out, right? If I now say, okay, I only want to look at this graph in a certain interval. I only want to look at this graph between this value and, let's say, this value, okay? That changes the whole picture now, because what used to be the maximum is no longer in the interval that we're looking at. So it's not a maximum in that part of the graph. And what happens is now I have to look for what is the highest y value in that interval. And that would be the point right here where it hits the line. That's the very highest y value I get in this whole interval. So we call that the absolute max, even though it's not one of those critical points or extrema that you find when you take your derivative and set it equal to 0. It is absolutely the highest point for the graph in that interval between the white lines. The minimum here in my example would remain as the critical point, the turning point that we see here, because it's in our interval. But the maximum is going to change and become this value because it's in the interval and the other value isn't. So I hope that makes sense in terms of what I'm trying to explain about this graph that we're working on. So what we have to do is we kind of have to check. We have to say, okay, the important places for this graph are when f is equal to, when x is equal to -1, when x is equal to that 0.3662 value that we found, and when x is equal to 3, because that's our left and right boundaries, the -1 and the 3. So what I actually have to do is just work out the y values at all of those points and see who wins, which one's the highest, which one's the lowest. That's when I say that's my absolute maximum, that's my absolute minimum in that interval. And so if f equals minus 1, I would get, if x equals minus 1, I would get minus 1 plus e to the 3. And I would work that out as an actual decimal value so that I can compare it to the others. And so I'll just do that on my calculator while I'm talking to you here. And I think we're going to get 19.08, okay? Now, for f at 0.3662, we already know that that comes out to 0.6995 because we worked that out as our turning point or our critical value. And f at 3 is going to be 3 plus e to the 9. And so I'm just putting that e to the, I made a mistake, e to the negative 9, sorry. I'm just putting that back into the f of x equation. And so if I take 3 plus e to the negative 9, I end up with 3, almost 3 exactly, 3.0001, sorry. So all I have to do now is compare those numbers. The lowest is this guy right here, so I'll put an L for lowest. The highest is this guy right here, the 19. And so in this interval, these guys are the winners for my absolute highest and absolute lowest points. And so now I can say, therefore, the absolute minimum is 0.6995 at x equals ln of 1/3 over negative 3, and the absolute max is 19.08 at x equals negative 1. Okay? So the difference between what I've got and what you've got is just in this value here. And I can't sort of, I don't know, ln of 1 over 3 is ln of 1 minus ln of 3. There might be a way to change that into what you've got, but I'm not sure exactly. I'd have to sit down and fiddle with that a little bit to see. I don't think there is, because this is negative and yours is positive. I guess one way to check would be to do ln of 3 and then divide that by 3. Yeah, we get the same thing, so that's interesting. So maybe in terms of the laws of logarithms, there's a way to change that into ln of 3 over 3, but we get the same value either way, so it wouldn't matter if you were doing this question and you got what I got, or you got the answer that you gave me.